All right, guys, we're back, and we're going to do two more examples of graphing rational functions. This time we're looking at this guy right here, x to the fourth divided by x squared plus 1. Again, we're going to follow the same procedure where we go down the list of those four things that we got to hit. The first one is going to be the vertical asymptote. Now, when we find the vertical asymptote, what you're going to do is you're going to set your denominator equal to 0. And what I'm going to do here is I'm going to put this 1 on the other side by subtracting 1 from both sides. Maybe that should be a different color. I don't know why my pen is so laggy right now. Then I'm going to have to isolate x by itself. So to undo the square, I got to do the square root. Remember, the square rooting a square will always produce that plus or minus effect. So I get plus or minus the square root of minus 1. But plus or minus the square root of minus 1, do you guys remember that negative 1 square rooted is represented by I, the imaginary number, right? So actually I have plus or minus I. So my vertical asymptote is at plus or minus I. Or actually, maybe I should say it's at plus I and it's at minus I. So remember before, what we did was if we found out that the vertical asymptote was at minus 2, we found minus 2 on the x-axis and we drew an invisible line. So the question here is, I'm looking at my x-axis and I'm trying to find where I is. Remember, the x-axis contains all the real numbers. And guess what? I is not part of the real numbers. So there is no I on this line. That means there is no vertical asymptote. So there you go. If an I ever pops up, just know that there's no vertical asymptote for it. Let's look at the horizontal one. Remember, horizontal asymptote, we just compared the degrees. The degree of our numerator here is 4, because we can see this guy right here. The degree of the denominator here is 2. He's the highest power on the bottom. So the degree of the numerator is greater than the degree of the denominator. So there are no horizontal asymptotes. I'm going to keep moving forward. The x-intercept, how do we find that? We set the numerator equal to 0. Thank God this guy is easy. If I raise both sides by 1 over 4, I cancel out these guys, and I'm just left with x. And 0 raised to any power is just 0, so I'm left with x equaling 0. So that means when y is 0, x is 0. So the origin is part of my graph here. And the same thing goes for my y-intercept. To find the y-intercept, you will let x equal 0, and you figure out what y is. Well, when I let x equal 0, I get 0 in the numerator divided by 0 squared plus 1, which is just 1. So I have 0 divided by 1, which is just 0. So when I let x equals 0, y also equals 0. And the same thing happened, where we know that the origin is going to be a point on our graph. Okay. So there are no vertical asymptotes, and there are no horizontal asymptotes. So what does this guy really look like? Give me 2 seconds. All right, so I have no real place to start because we said to pick x values that were close to your vertical asymptote, but we don't have one. So I'm just going to start picking random numbers that are near my origin because I know this guy right here, 0, 0, is a point on my graph. So what I'm going to do is I'm going to pick x values that are close to the origin, such as minus 1, 1, minus 2, 2. And if you see, once we graph it, or once we find what the y values are, they're kind of mirrored, meaning when x is 1, I get 1/2. That's this line right here. Oh, sorry. That's this line right here. When x is minus 1, I also get 1/2. So it looks like this. When x is minus 2, I get 16 over 5. When x is minus 2, I get 16 over 5. And when x is 2, I get 16 over 5 as well. So we have enough points where we can kind of connect the dots here. Our graph looks something like this. Boom. And boom. So it's pretty much a parabola. Interesting, right? Well, it kind of makes sense. If you remember how to do the polynomial division, and if you divide this through, you'll see why it makes sense. Okay, well, that's an easy one. I made that one an easy one because, well, the last one's a little bit more challenging, and it's going to be the most complicated out of all of them. So here we go. Let's just get rid of it. So our last one is right here. F of x equals 3x squared divided by x squared minus 4. Of course, we follow the same procedures where we find the vertical asymptote by setting the denominator equal to 0. Oops. So x squared minus 4 equals 0. Then I add both sides by 4. So I have x squared equals 4. To isolate x, I have to take the square root. When I take the square root of a square, I have this plus or minus factor right here. So I have x equals, well, this one will lead into x equals plus or minus the square root of 4, which is 2. So that means I have a vertical asymptote at x equals 2, and I also have another vertical asymptote at x equals minus 2. So this is our first instance where we have two vertical asymptotes. So let's go ahead and look at our horizontal asymptote. We're going to compare the degree of the numerator and denominator. Degree of the numerator is 2. Degree of the denominator is also 2. If the degrees are the same, we take the leading coefficients. The leading coefficient of the top term right here is 3, and the leading coefficient of the bottom term is this guy right here, which is an invisible 1. So we have 3 divided by 1, which is just 3. So our horizontal asymptote here is at y equals 3. All right, moving on. We're going to find our x-intercept. Our x-intercept can be found by setting the numerator to equal 0. So let me just break this down for some of us. So I'm going to divide both sides by 3. So I have x squared equals 0. And I take the square root of both sides, and this will just lead me into x equaling 0. So that means when y is 0, remember we set y to equal 0, x is 0. So that means our graph crosses the origin again. Well, I mean, the same thing will happen for the y-intercept. So for the y-intercept, we're going to plug in 0 for x. So when x is 0, what do we get? You do a bunch of algebra, and you find that y is also 0. So again, these two sentences are saying the same thing. These two guys are saying the same thing. They're saying that your graph will cross through the origin because this occurred and this happened. All right, so let's go around, same procedure as before. And this time, the unique thing about this is that we have two vertical asymptotes. The first one will be at x equals minus 2. Boom, 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 boom. The other one is at x equals 2. Boom, 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 boom. There we go. So x equals minus 2, x equals 2. And we should probably put in our vertical asymptote somewhere, right? I mean, our horizontal. So here's our horizontal asymptote, 3. And here he goes. And we have y equals 3. I just want you guys to know that it's very lonely to teach and not have an audience. It's kind of boring. I'm not going to lie. Changes the whole dynamic for me. Do I even want to do this anymore? I'm joking. Of course I do. I want a paycheck. All right, so what else do we know about this? The other thing we know is that this point right here, let me just highlight it. 0, 0 is on my graph, so this guy is definitely a point on the graph. Okay, so remember, we're going to start plugging in values for x, but I should always pick values that are to the right of my asymptote and to the left of my asymptote. So let's just look at this first asymptote right here that at x equals -2. I'm going to pick a number to the right of it. So in this case, it will be this guy, -1. Then I'm going to pick an x value that's to the left of it. So in this case, it will be -3. And you could pick any number to the left or to the right of it. It's good to keep close to your vertical asymptote, so just slightly to the left or slightly to the right. But it is okay to pick, like, rather than -3, you can pick, like -5 or -10. It's okay. But I like to stay relatively close to my vertical asymptote. Okay, let's see if we can undo this highlighting. Good. And the same thing goes for my other vertical asymptote. This guy, my vertical asymptote is at x equals 2. I'm going to pick two values, one to the left and one to the right. The one to the left will be x equals 1. The one to the right will be x equals 3. Good. So I'm going to pick -3, -1, 1, 3, and 4 for just fun. And I'm going to put all those x's into my function, and this is what I get. When x is -3, I get 27 over 3. I think that's a 5 actually, 27 over 5. Let me just double check that for us. Yep, that is. When x is -1, I get y is -1. When x is 1, I get y is -1. When x is 3, y is 27 over 5. When x is 4, y is 4. So all we're going to do right now is we're going to start plotting these points. So let's start with the easiest one, which is 4. When x equals 4, I have 4. So he will be up here, 4, 4. When x equals 3, we have 27. Oh gosh, hold on, I gotta extend this. We have 27 over 5. So that will be a little bit greater than 5. So let's just say here's 5. So 3 is going to be a little bit greater than 5. So here's our second point. So we just did 4, and now we just did 3. Let's look at 1. When x is 1, our value here is -1. So we just did this. When x is -1, our value again is -1. So right here, boom, 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 good. So we did this guy. Lastly, we have when x equals -3, we're going to have 27 over 5 again. So remember, this guy right here was 27 over 5. So let's match them up, 27 over 5. Honestly, you should do one more. You should probably do -4. And it's going to look something like this. It's going to be, I didn't do it, but you guys can do it for practice. I don't know why I didn't add it in this one. But now our goal is to just connect these dots, okay? So let's start with the left-hand side. So I'm going to connect these dots in a way that I avoid the vertical asymptote. So I want to connect these two dots, but I'm going to veer my graph out of the way so it doesn't hit my vertical asymptote. Good. Let's go all the way to the right now. This guy's going to be very similar. So I'm going to connect my dots, and I'm I'm going to veer out of the way so I don't hit these vertical asymptotes. They're going to come very close to the vertical asymptote, all right? So try not to do something like this where you're veering like this. No, that's a mistake. They're going to come pretty close to our vertical asymptote, but they're not going to touch it. Lastly, we have these 3 dots, 1, 2, 3, and we want to connect these 3 in a way like this. And this guy is going to just hug our vertical asymptote to the left, and this guy is going to hug our vertical asymptote to the right. So it's actually just like a smiley face parabola. And if you guys are unsure, or if you feel like you don't have enough points on your graph to really figure out what's going on, maybe let's look at this left-hand side right here. And my pen is lagging again. Maybe you're here and you're just not really sure how to connect the dots. Guess what you should do? Just plug in more values, all right? Maybe you could plug in minus 3.5, okay? And then you'll figure out that it's going to look something like this. Or you could pick numbers that are between -3 and -2. So it's going to look like this and this. And so the more unsure you are, the way you can ease yourself is by just plugging in more x values and then finding out where the y values are. So if you want to plug in 5 dots, go for it. If you want to plug in 2 and then use the asymptotes as a guideline, go for it. Just make sure our graphs never hit these asymptotes. All right, guys, keep doing your homework. I know this is a hard one. This question will definitely be on your final, so keep strong and keep studying, guys. See you there on the next one.